Hi, I'm Ed O'Keefe from Enterprise Equipment. We're at the Boston Public Library, Rare Books, heating cooling system. Right, today we're going to go over the chilled water pumps. There's two 7.5 horse Taco pumps that feed the chiller and the air handler for the Rare Books 4th, 5th, and 6th floors. The 7.5 horse Taco pumps with a suction diffuser. There's a screen in here, and there's a drain on it to flush it. There's also a triple duty valve over here, which is a balancing valve, check valve. So the system's all been professionally balanced, so you don't change any settings. The pumps are going to run automatically. There's complete redundancy, so there's two pumps, one size big enough for the chiller. The minimum speed of the pump will be enough that the chiller needs 118 gallons flow. So the minimum speed of the pump will match the chiller minimum flow. These pumps pump through a dedicated chiller that feeds a dedicated air handler for the Rare Books. They have 30% glycol mix, and they go through an air separator right here. There's a makeup glycol pump over there that maintains the pressure in the system. They don't make up city water. You have to make it up with glycol. They're a mechanical seal pump, so they have a bearing lubrication line, a 1/4 inch lubrication line, and that's open all the time. They're fully insulated because it's chilled water. There's not much else to them, because if you didn't have the glycol in there, you would have to worry about water treatment. But this is a short feeder, so if you had to add inhibitor to your system, you open the valve, the in and outlet valve. Well, first you drain it, you open this, you add your chemicals, close it up, open the two valves, and the discharge of the pump will push the system water through here and adds the chemical to it. There is a funnel, a fill funnel here, but make sure the valves are off before you open the top. Add that, pour your chemicals in, and you probably have a water treatment company with the library. I'm not sure. We're here at Rare Books. The same the chilled water pumps. These are the two drives that control the chilled water pump 1 and 2. They will be running in fully automatic because there's a differential pressure sensor. So as the valves open, the pumps will speed up and down. So typically, it reads out the frequency and the amperage. So typically, it'll be running automatic. If for some reason the computer program was not working, you need to run them. You can run them on hand, but you don't know what the differential pressure is. So almost always there'll be an automatic. And if one pump fails, the other one will automatically turn on. Right now we're running at 49 hertz, so the valve is probably halfway open. And if you have a fault here, the only way to reset the fault is the red off button is the reset. And then when you're done with that, you press auto, and it should return to automatic. If that doesn't happen, it should automatically swap over to the other pump. That's part of the BMS training, and that's out of my realm. But these are the drives. There's a disconnect switch. There's an automatic bypass, and typically all you want to see is auto, and that's it. The differential pressure sensor is on the glycol piping, 2/3 of the way down, just before the pipes go up to the chiller. There's two taps with a differential pressure transducer that runs these pumps. So when the valve opens in the air handler, then the pump will speed up, or as the valve shuts, the pump will ramp down. And that's about it. Okay, we're here at Rare Books. This is the glycol makeup feeder for the chilled water system for the chiller and air handler. You can't just add Cdi water to a system that has glycol in it because it would dilute the mixture. So we're trying to maintain a 30% glycol mix. It's a polypropylene glycol, so it's non-toxic. And you can add some here, but you can add 30% mix so that when it pumps into the system, it's already at the right level. This is the connection to the air separator on the pumps. So whenever that pressure gets too low, this pressure switch will sense it and turn on that pump. If for some reason the pump pressure gets too much, this relief valve will dump it back in. It'll rat race the fluid. This suction stays open. It's a small pump, so it takes a little bit, but you're not going to be losing. You're not going to be losing unless you have a major leak. You're not going to lose anything. That'll be able to keep up. Switches. This one stays on. This one stays in auto, and the alarm can stay on. So what happens is, if this pressure drops, the pump comes on. Provided there's fluid in the tank. If there's no fluid in the tank, then the pump won't run, and you'll have an alarm. So there's a float switch in here, a tethered float switch that floats. If there's nothing in the tank, you'll get an alarm. Now you can shut the alarm off, but the pump won't run. So even though you silence the horn, the alarm is still on. So typically those three switches stay to the right. And this is a relief valve. So if there was a blockage somewhere and this pump was making 40 pounds, then this relief would just dump it back in the tank. I believe this is tied into the EMS, so if the alarm goes off, the building management system will know that there's an alarm. So if the level gets too low, you'll get an alarm. And that's your glycol makeup feeder. So you don't want to add Cdi water, but if you had to add glycol to this tank, there's a hose spigot here with Cdi water. You take a hose, a wash machine hose from here to add the water. So you put in 5 gallons of glycol to 10 gallons or whatever equivalent to get 30% mix. If you put the concentrate in, if you buy the glycol already at 30%, then you pour it in full strength.
How long does the glycol last?
You should have it tested every 5 years or so, see if it has lost any of its rust inhibiting capacity. But in a closed system, it usually lasts you 10 years. Yeah. We're here at Rare Books heating project, and this is a heat exchange. This is a heat exchanger that serves uses the building chiller if for some reason the chiller that's dedicated to Rare Books is inoperable. They can swap it over automatically by opening these valves, and they'll take the building chilled water to chill the Rare Books air handler. This is only a backup. Typically, the chiller that's dedicated to Rare Books will serve the air handler. And this is only if the chiller is inoperable, these valves will open, and they'll use building chilled water to do the same thing the chiller does here. And it's an Alpha Laval chiller. It's the reason they leave these rods long is to clean it out. It's a plate and frame heat exchanger. So when it gets plugged, you have to service it. You have to take it apart and get new gaskets in there. You loosen these nuts and you slide the plates apart to clean them. Where we're using glycol, there's less chance of corrosion and plugging. But if you notice a reduced capacity, then it needs to be serviced, needs to be cleaned. But that's probably not going to happen very often here because of the glycol with the inhibitor in it. And this is fully automatic, so like I say, it's only a backup system. We have these insulated panels so that it won't sweat, and it's all hinged, and that's about it. Are there any questions?
I have to read this disclaimer real quick on videotape per my company's rules. So it says you're about to watch a videotape of a startup training being provided by Daikin Applied on May 13th, 2021. The video is intended for the sole purpose of supporting Daikin's published procedures and is not intended to replace Daikin factory owner-operator training. Equipment, startup procedures, service processes, etc. change over time. Daikin does not warrant the timeliness of the information contained in this videotape, and Daikin assumes no obligation to update the information presented in this training session. In addition, the information presented in this training session is designed to improve only general startup information and training and is not intended to be all-inclusive with respect to product, maintenance, or service issues. If you need advice about a particular maintenance process, product, or service issue, you should consult with a Daikin Applied service professional. The applicable data sheets, product manuals, and instructions for specific Daikin products being serviced or maintained should be consulted for information about that product, including, without limitation, information regarding safety, maintenance, operation, design, installation, care, warnings relating to, and proper uses of each Daikin product. In addition, training is typically better when it can be done in person. That gives the person being trained the opportunity to ask and seek clarification on any confusing issues. Daikin specifically disclaims all liability for errors or omissions in, or the misuse or misinterpretation of, any information presented in the training video. The video is intended for direct employees of the owner and may not be reproduced or shared with any third party without Daikin's prior written consent. If you have any questions, please hold them until the end of the training session, and I will answer them after the videotaping has concluded. All right, so formalities out of the way. Again, my name's Sean with Daikin Applied. This you have an AGZ chiller, air-cooled. There's not a whole lot of user maintenance to it. You can see if you go underneath, it has they almost look like radiator coils. They're a newer style coil. They're aluminum. There's no recommendation for actual chemicals to be used on them. Water is really the best thing. Any of the older chillers or older equipment you may have seen have very thick coils. These are very thin, just like I said, similar to the radiators in your cars. They can be blown out pretty easily with just a water pressure from a water hose. Anything else inside the unit, we'll walk over real quick and look at the Microtech, and I'll show you the controller. Anything else is really, it needs to be serviced by a professional. There's no user maintenance per se, besides cleaning the coils and just checking the controller to make sure everything's functioning well. If we could just walk around the corner real quick and I'll show you the controller. All right, again, my name's Sean. I'm with Daikin Applied. We just moved over to the other side of the unit. As you can see, the unit controller is right in here. You have your on-off switches. You shouldn't really ever have to mess with any of that. You have a small fan up here for a high ambient. Only thing really you can check with that, just make sure it's not blocked with any leaves or anything. It keeps everything cool inside, draws air through. Anything else with the maintenance, there isn't so much to do. On the controller itself, there is a way, if you have an alarm, it will show in the top right corner. It'll be a small alarm bell, looks similar to the alarm bell right here. It'll be moving back and forth. If you hit that button right here, it will take you to an alarm list. The It'll have your active alarms. It'll say how many alarms are active. You do not need to put any passwords in to access this list. If you click on the alarm actives, all you do is hit the enter button. The enter button is the dial itself. Just push in. Right now the alarm count is 0, so there's no alarms. If there was an alarm, you could clear it on this same page. Right next to it, it says alarm clear. You would click again, and you could scroll with this dial to alarm clear on, and it will clear anything that is able to be cleared. Anything else on here will show you your active set points, your leaving water temperatures, the percentage of what it's running right now. Again, not much else. If there's any issues, I wouldn't recommend to reset alarms continuously. If you have an alarm, you may think it's not a big issue. It may be, it may not be. You could try and reset it once. If it comes back, that's when I would call someone out to check it. Unless you don't feel comfortable, it's always best to just call and see what's going on, have someone come out and check it. Other than that, there really isn't anything else.
Okay, we're at BPL rear box, Copley branch. We're going to go over the variable air volume boxes. The VAV box, they each have a tag on them. This is VAV-I, and that one up there is VAV-J. If you look at print M300, there's a schematic, so you can trace out where everyone goes. VAV-I feeds the 417 stacks. So this goes down to the 4th floor, 417 stacks. And it's a basic damper in a box with an airflow station. They're made by the Naylor company. Each one's sized differently. It's simply that shaft marking, when it's horizontal with the ductwork, it's wide open. It's throttling down right now. There's an airflow sensing tubes here that go right to this controller. The VAV controller has a space sensor and will control airflow to that to match the demand. Also, this is linked to a reheat coil because we're bringing in the cold air from the rooftop unit and air handler, and as needed, the reheat coil valve will open and close. They'll go over more of that on the ATC training, which is in a few weeks. Any questions on this? No? So this is Kmc Damper Actuator. It's actually a VAV controller. It has the sensing lines on it. It has power. It has a comm line. And it also controls the valve, the reheat valve. Now, one other thing that will happen is over on this duct, every floor it goes through a fire smoke damper. If they shut, you'll get no air in your space. They're tied into a smoky vac panel too, also. So the fire alarm will close the fire smoke damper, and after the fire's out, they have a button they can press on the 4th floor. It'll do smoky vac, and certain dampers will open, and certain ones will stay closed. There's a list in the drawings of which ones are on smoky vac. So this is VAV-I and VAV-J. So they all both serve the 4th floor, different sides of the stacks. When you leave each floor, there's a fire smoke damper, so you can't transmit fire and smoke between floors. So every time transitions from 7th to 6th or whatever, there's a fire and smoke damper. There is a test switch here. Usually it stays in normal. And then if the duct smoke goes off, there's a duct smoke detector here. If that goes off or the fire alarm trips, it will actually close this damper. And you can see the shaft. And also, there's an access door right here where you can see the damper to verify that it hasn't slipped on the shaft. Each fire smoke damper is numbered. So this is 18, and 19 is on the upper box, the box J. So there's 2 right here. There are some fire smoke dampers that are actually in the return grill. So you can look in the louver and see the damper in there. And that's about it for here. So we're at Rare Copley Library. This is a duplex condensate pump. So the reheat coils are powered, served by a heat exchanger that takes steam to water heat exchanger. Existing steam to water heat exchanger and existing hot water pumps for the reheat coils on the VAV boxes. So when that water condenses in the heat exchanger, it comes into this condensate pump, and this pumps it back to the system. So there's a alternating duplex float switch. Every time it turns on the opposite pump. So one time it'll be pump 1, the next time it'll be pump 2. If it's the water still keeps coming in and it can't make it with one, it'll bring on the both pumps. It'll bring on both pumps and sound an alarm. That's abnormal. So if that happens, you should check the other pump. Usually that means one pump failed and the second one had to come on and pump the water. That alarm switch usually stays up in the on position, so it will buzz if there is a problem. Both pump switches stay in the automatic side. There's a handoff auto, but you'll leave them in automatic. And there's a sight glass here. So about halfway is where the float will turn on the first pump. And typically, if things are normal, that pump will come on and off. If for some reason that first pump doesn't come on, it drops to the water level becomes higher, and it turns on the second pump. And that's basically it. It's a duplex condensate pump. There's 2 system exhaust fans. EF3 serves the conservation lab. On the 4th floor, there's a fume hood, and there's an EVAV, an exhaust VAV box. And there's also another one for the lab itself, not the fume hood. This fan serves both of those EVAVs. If either one of them has a call for exhaust or it's in the schedule, this will ramp up to the desired set point. It's always going to be an automatic, and if you have a fault, and there's a fault on the screen, the red button is your reset. So typically this will just be an automatic. So see, if you have a fault, then you press the red button, hold it. Once the fault clears, and you should be able to hit automatic. Sometimes you have to hit the reset first, upper right hand button, to clear that fault. And it's always easier to just recycle the power. Once the fault clears, you hit automatic. And the fan starts ramping up. This exhaust fan is on the roof. We'll go up and look at that in a minute. That's EF3. And we'll also be looking at EF2, which is the dump fan on the return air. If we have too much return air, we have to exhaust some of it. So EF2 is a 5-horse exhaust fan up on the roof, teed into the return air ductwork. So it's the same drive. It's an APA drive, so same thing, same reset, same everything you're looking at should be an automatic, and then the building management system will control it. And that's about it for the VFD, for the exhaust fans. We're at Copley Library Rare Books project. This is exhaust fan 4 on the 5th floor. It's exhausting this emergency electrical room to get rid of the heat from this transformer. The transformer generates a lot of heat. We have a transfer grill here, brings in air, and this exhausts it to the roof. And it's 90 CFM exhaust fan. Also in here we have fire smoke dampers and duct smokes. And more duct smoke up here. They're all on the drawings, and they'll go over that when they go over the fire alarm details. That's it. We're at Copley Library Rare Books project, and this is an electric duct heater. It's 1 kW, 460 volts. Has a built-in airflow switch and the controller right here from the building management system. So when the air is flowing to that room, this will be powered and provides electric heat. It's just one spot where they didn't have steam heat for it. Okay. This is exhaust fan 3, feeds the conservation lab. It's fed by 2 EVAVs, 2 exhaust VAVs. One's a fume hood, and one is the just a general lab. It's a 1/2 horse belt-driven exhaust fan. Just discharges straight up. It's all stainless steel ductwork coming from the lab, and inside the building, it's all insulated with fireproof insulation. It's 1/2 horse, 460 volt belt-driven fan. That's about it you have on this exhaust fan number 3. Exhaust fan number 2, we'll go over that in a minute. All right, we're here at Rare Books Copley Library, Boston Public Library. This is exhaust fan number 2, which is a relief exhaust for the main system. When the control system opens this damper and starts that fan, it discharges out here. It's on a variable frequency drive, depends on how much return air pressure we have in the ductwork. So once again, it's a 5 horsepower belt-driven fan. Exhaust fan number 2. Basic 5 horse belt-driven fan. That's about it. It discharges right here. So it's teed into the return for the air handling unit. So when the duct pressure is excessive, this dumps the heat out. And that's it. We're here at Copley Library Rare Books. This is exhaust fan number 1. It serves the 4th floor bathroom. It's a 100 CFM mushroom fan. Under CFM mushroom fan with a ECM motor on it, and it's on the schedule, so that when the bathroom's occupied, it'll be on. And it's just 100 CFM. And thank you.
Hey, my name's Tom with ACS Engineering. I'm a manufacturing rep for Haycon Industries. We're going to do a walk through the unit and kind of basic procedures on how to take care of the unit and maintain it. This unit right here is AHU1. So this is the supply fan section. You have 2 direct drive motors. They do have 2 greasing spots right here, the motor itself and the bearing up front. We recommend, greasing those, roughly every 6 months during the maintenance that gets done to the unit. You've got 2 DPs there, which you saw earlier. Those run outside. There's a Coil controller that'll show when we go out there that's displaying what the CFM is of the unit, what's going on. Above you is a support beam. This would come later down the road, I'm sure, if you ever had to replace a motor a couple of years down the road. It can carry these motors, which is nice to throw on a chain fall and drag it over to the outside of the door over there. There's not much more really in the section. There's a coil here. The coil itself, we'll get further on it down the line of the unit, but basically every section of a Haycon unit is technically washed down. It can be washed down. Now that being said, it doesn't mean everything inside of it is. Like this obviously isn't a waterproof sensor, but as far as the material, the walls go and everything like that, it can get wet. So if for any reason we ended up getting really dirty unit way down the road somehow into this section, which is probably very unlikely, it can be washed. Ideally, you'd want to wash it, the way it came.
Yeah.
But
I can use compressed air and make it.
yeah, I mean, ideally, you'd always want to use that as a first resort because water's a son of a gun. So, but yeah, light vacuum, that type of stuff, if it has to be done. But other than that, you should be fine on this section. And there are drains here, like I said. So
Different weight range springs.
correct. Yep.
Okay.
It's all based on weight.
And humidity sensor right there.
Yeah, so that's going to be John's. That'll be Zenergy sensors. But yeah, it's a temp humidity sensor from what I can tell.
Thank you.
Yeah. So right here, I want to focus on a couple of things. We have both of our supply fan VFDs right here. There's nothing that needs to get done to them, really. They're good to display if you're doing a maintenance contract and you come up here to look at the unit to make sure that it's not an alarm, or if it is running, that if you shut it down, you shut it down correctly. Both the off buttons here will shut down both drives. Try and make sure you shut them off at the same time so there's no pull on the motors. Right above here is the airflow. It's a Coil controller, just displays what you can see of the CFM of what's going on with each fan. Up here, Zenergy has a low pressure, high pressure cutout switches. This is to safety, to shut down the fans if needed. We also have a main disconnect right here to the other side of the wall, which kills power to everything past this disconnect to the VFDs to the motor. Another nice thing I like to mention is the display of the doors. As you can see on this door, it closes in, and there's a flange on the outside. This is just basically tell you that this is going to be a positive section. This is to allow it so when you open it, the door does not come and hit you. On the inside, you will notice that the door is closed from the inside against the groove. That is because that is going to be a negative section, and that'll stop the door from actually pulling into the other section. You got a little baffle up here just to release air. Recommended in the summer to open that. There's another one opposing against the unit on the supply side that will dump whatever the supply fan temperature is coming in here, or the discharge air, which I probably assume is going to be 55 degrees. In this section here, we have our supply fan gravity dampers. This is to allow, if needed, one fan off for any reason. If a fan goes bad, it'll stop it from backspinning. Ideally, it should work very well. As you can see, a little bit of pressure will open them up, but they'll close once they lose the actual grip of the fan. Over here, we have a bypass damper that bypasses the heat wheel. And this is the heat wheel itself. The heat wheel is going to have a belt. I don't believe there's any grease spots on the motor. When we get around, I'll take a look, but I'm almost positive there isn't. The belt itself, it's just like any other belt, should be checked periodically. Maybe every 6 months when you go to grease the motor, just check it, bend it, make sure nothing happens to it. If it looks like it has signs of corrosion of it breaking, then I recommend replacing it. There are grease spots on the hubs for these wheels. That might be something to do as well with the motors. It's not as aggressive as the direct drive motors, but maybe yearly you just grease them up. Make sure you don't overdo it. You can blow the bearings on it. But that should be it in this section. Right here we have our heat wheel VFD and the controller that's tied in with the wheel. This controller here is basically to use it to be able to control the wheel based off of temperature. It allows it to have its own internal defrost method. This is also tied in through BACnet with Zenergy for them to take a look at it and be able to control it and manipulate it while they see fit. We can take a step into this section. This is the other side of the heat wheel and the humidifier section. This is where the grid is for the humidifier that runs from an Ebtronic humidifier. One thing we can last say about the wheel is if it does get dirty, to make sure to try and clean it with compressed air back the way it came. Meaning this section you should be blowing it or blowing back that way. Ideally, the most we ever want to use on this is compressed air in a vacuum. These should not see water. There might be a call for it if necessary, but that would be a very large extent to be able to decide to do that. It should not see water if it can avoid it. This is the humidifier grid. There's not much to do with this. There's no kind of maintenance you should have to do with it. I would just periodically check it and make sure it's dispersing correctly. It is RO water, so I highly doubt you're going to see any kind of corrosion either, up to this point. If you do, way down the road, then maybe we recommend replacing parts of this grid or any of the nozzles inside. But other than that, you shouldn't have to do anything with this. Right up against here, I believe we have our heating coil. Just like I had mentioned with the cooling coil and the rest of the coils. They can be cleaned with water if they need to be. Ideally, if filters are maintained, you should never have to worry about the coils and clean anything with them. And that should be good for this section. So this section here is for our pre-filters. Pre-filters. These are charcoal filters. They're a little more controlling than your normal filters. The recommendation of replacing filters is going to be strictly based off of location. I can say every 3 months I recommend changing these, but I've found that every location is most definitely different compared to what I can recommend. My assumption is most people that are going to be working on this unit work in the area, and with that being said, they probably have an understanding of when they should be replaced. There is going to be a magnet helix right there on the other side of this wall that can be set for a differential pressure of when you see fit to change these filters, whether it be an inch or an inch and a quarter. You can check to see when you need to change it, and that'll do it here. Okay, this is our mixed air section here. Again, another set of pre-filters on this side. Same thing goes for the ones I just mentioned. My recommendation of replacing them is all going to be based on location and how fast they get dirty. Right here we have our return air coming into the unit, and then our outside air. Next to the outside air damper here, we have a Ebtron flow station. This flow station, nothing needs to get done to it, but it does display what the outside air CFM is coming into the unit. This reverts back to Zenergy and allows them to see what we're doing. And in this section right behind you is another damper. This damper right here is going to be your supply damper. In this section we have our supply damper. When it comes to all three of these dampers, there's not much maintenance that should ever have to get done to them. If it is way down the road, a recommendation of cleaning is a possibility. If it needs to get wiped down, it can be. Nothing can really harm it per se, but it shouldn't have to get done on a regular basis when doing a normal maintenance on the unit. There's a number of sensors here that are Zenergy's. I can let them go more into depth on it if they want anything done with those sensors, but as far as that goes, everything in these sections should be easily maintained and mostly just filter changes. So this is an Ebtronic humidifier. They're very small. They're very simplistic as far as the humidifier industry goes. This right here is where you're going to actually be holding your RO water. It's very easy to actually do maintenance on these, which is why I actually enjoy the Ebtronic line as a manufacturer. These two clips here can unbuckle, and you can disconnect this. They use fire hose connections to be able to connect this lining. After that, these can open up and it'll drop down and slide on a rail. You can pull this out. Now the time you'd have to do that is for scaling cleaning. It is RO water, so the chances of actually having to clean this as far as because of scaling goes is very minimal. The RO water is meant to obviously completely decrease, if not get rid of the fact that you have scaling. I believe when I started these as well that they were set up for 6-hour dumps as well to make sure that we're not holding a lot of water inside of this thing to make it build up or add any issues. On the left side here, you can see this is where your meter is for your leveling of filling on the tank. You have 3 probes in there. One's really low down, one's up in the middle area, and one's up high. Obviously, there's a low and a high, and the middle is where you want to be. There is a display here. There's not much that would have to get done here, but it will show you what state it's in, what kind of demand it's in, and how it's operating. These are being controlled by Zenergy as far as the demand goes and enable. So if it's not running, try not to blame the humidifier right off the bat. It is taking a 0 to 10 volt signal and an enable from Zenergy based off of, I believe, an average of room humidity. In here is our board. You can access it at any time. There's nothing that needs to get done in here. I don't recommend really ever going in there. And they come with a set of keys. These keys are to lock and unlock everything around the humidifier itself. There's an external pump connected to this to push towards the drain. I can't say whether or not maintenance needs to get done to it one way or the other. If it does, it would be way down the road. If it ends up getting way too, clogged up for whatever reason. There is a high limit tied into it with a shutdown. This is to stop overflowage and external temperatures. If it needs to, it'll shut down the actual humidifier from draining. There's a manual drain lever too on this side that I can show. On the back in here, if you need to, you can reach in there and there's a little ball valve that you can open up to drain the tank manually. If not, you can press and hold this button right here on the screen. This will drain the tank itself. And there's a manual shut-off right here for the water to the actual humidifier itself. And this right here is an overflow underneath the tank in case it ends up leaking. It'll come down in here and still go through the drain. Other than that, you should be good. So this right here is a Cdi unit. The purpose of this unit is strictly dehumidification on a high level. I believe when I was doing the startup of this, I had at full throttle, I had about 2.5% RH coming out of the supply duct. Inside it's pretty simple. You just have return filters, outside air filters, which are here and here. There should be, I believe, only one on each side. Those again will be changed off of base location and how often you think they got to get changed. Obviously, I expect the outside air to be changed maybe more frequently, depending on how the room's taken care of and why it's serving that library room. Probably tells you to be taken care of pretty well. You got a deskant wheel inside of here. This one's a little different than the one up there. The only reason I say that is obviously location based. As far as maintenance goes, I strongly recommend if you make sure of any filters that get changed, it's going to be this. Because if that gets dirty, there's not an easy way of cleaning it. And frankly, if it gets dirty enough, there isn't a way of cleaning it, and it'll have to get replaced. You have magnet helix here for both filters. You can set those to what you think is fit based off of when you believe you need to change them. Again, whether that be 1 inch or 1 1/4 inches. It's all based off of location. Right here is where your main electrical cabinet is. This is going to have the terminal blocks in there from Zenergy and me, fuses and relays. I don't believe I need to open it, but if you want to take a look, you can. Underneath this side on below this panel is another door in there. It's just more electrical connections. It's going to be, there's 2 limit switches in there for DPs and then transformers. There is a controller, which we'll go around and take a look at here in a few. It's mounted on the wall on this beam right over here. It's a Coil controller that's wired across the side. That'll show you what the unit's doing. And you shouldn't have to manipulate anything in it. There is an off switch right here, nice and easy. You just toggle switch off, throw it back into auto when you're done, when you're doing maintenance. Zenergy will be able to take control of it again, and they should be good. You can put some kind of a lubricant on the chain every now and then just to keep it, non-rusted, I'd say. A little WD-40 wouldn't hurt it every now and then, but don't overdo it. But other than that, it's really just filter changes. I don't believe these motors... Oh, they do. Oh, no, they don't. Yeah. So these motors here, the direct drive motors, do not have grease spots. They're internally greased because they're below a certain limit on sizing. So you do not need to grease them. So nothing should have to get done to these motors. Maybe, I can tell they're a little dirty. Maybe if they collect dust or anything up in here, maybe compressed air on it wouldn't hurt from getting inside the windings, but other than that, it should be good. So this right here is a Cdi Handheld Controller. This is a Pico 5 handheld. There's not a lot that you'd ever have to do here. It's just a reference to be able to see what the unit's doing. And if it is running, you can see that it's running. What it's doing, it can show you the temperature and the humidity that we're looking at based off the space demand. This does control a chilled water valve as well. This valve is external for a VAV. We just use that to make sure we can maintain the best humidity downstream. It's not actually in the unit, it's not our coil. And you can see the leaving air temp based off of the coil. There's a little more information here that you can see. None of it's something you should ever have to worry about, but it can see what the set points are, you know, what it wants leaving the unit, what it needs coming in. It can tell you what the call is for the unit itself, whether it wants dehumidification, whether the flow is running, whether the return's running, the wheel's running, any of that good stuff. It also has got a limit here to show you the runtime. It'll tell you how many hours it's been running, which is somewhat nice because you can eventually base your PMing off of the runtime. And that's it. Pretty easy controller. So, this is a Nebtronic RO skid. This skid feeds all of the 7 humidifiers up in this mechanical room. The maintenance that needs to get done to this is primarily these 3 filters and adding salt to the system. I mentioned earlier when I was speaking with one of the gentlemen here is that the recommendation as far as changing these filters is going to be based off of run time. You know, if it's in the winter and it's running for, 2 months on and off, my recommendation would be to change these filters. You'll see a spike in the system pressure. The system pressure, I believe, is dialed in for 125 from when we started up this unit. If it starts to rise, you don't want to go above 140. So if you start getting closer to that, that's a recommendation to be able to replace these filters. If you're going to replace one, replace all 3. There's no sense in replacing one just because you believe that's the one that's causing issues. You want to keep them all in the same kind of loop as far as operation. Adding salt inside the tank right now, it's about, I'd say 30%, 40% full on salt from the bottom of the tank. That's a good place to keep the salt level at. You want to make sure that there's salt always in this tank right here to make sure that we're able to adequately create the RO water that we need to create. Behind it is the filling tank. You can see right here it says tank full. This LED will light up when it tells you it's full. There's a float inside there that's going to come back to the system to tell it that it's full. If for any reason there's a clog, there's a manual ball valve on the bottom that you can tie off to. Down the line on this line set, further down you can see a manual ball valve. If for any reason you need to dump this entire tank, the recommendation is going to be to tie off to that ball valve downstream with a hose, go to a drain, open up, run the pump. You can manually shut this off. You know, you can even just kill the water right here to it and then start running that pump. You know, while you're doing that, you're going to lose your DP across the pump, which is going to let it drain. It's not something that should ever really happen, but for any reason that it does occur, that's the easiest way to do it. There are 2 membranes inside of these canisters right here. Those shouldn't have to get messed with. If they do get replaced, they're going to come with 2 O-rings. Just make sure. I actually left this here. You can buy this at Home Depot because I've already had to do this when I started up the equipment. It's waterproof grease, kind of like you'd find for plumbing, any kind of spicketing or anything like that. Just coat the outside of that on the gasketing to make sure, kind of like a silicone to hold it all together. And then right here, I can give a better breakdown. These pins right here, they're connected to a plate right here, or one kind of a U-shaped pull pin. You can pull that out. This comes out, and then you can grab the whole membrane and it comes out. That again, that would be after we ran for a while down the stream later on if we need to replace them. It's not something that'll be done regularly like these filters. As long as these are maintained, those should be good to go.
Piece inside the membrane?
Yeah,
Okay.
yeah.
We
So
have enough height to get them out of there?
yeah, so These have clamps right here. Like I said, I've already had to do this, which is good for you, I guess. But you loosen these clamps, yeah, and then you're gonna want to drop it because the axle clearance straight up, you technically don't have.
Okay.
So, but if you take these clamps off, you can turn it. Recommendation, the way I did it in general, was just take this off here, unscrew right here, and unscrew the bottom, and just take the whole thing apart. You can take the whole canister up, bring it over here, put it in a bucket, take it apart easy, make it easier on you, and replace the membrane. There's a pump down here. There is no grease spots on this pump. There's nothing that should have to get done to it. This is the disconnect for the pump, and it just feeds the humidifiers. The tank right here, which is what filters in and runs the water through from the street water. There's a display here that's already been all programmed. There's nothing that has to get done to this tank. You don't need to do anything to it. It shouldn't. It shows you a time frame on what it's doing. And you got some manuals here. And I believe there's even just a maintenance menu here that we can go over afterwards, which is friendly enough. But other than that, it's pretty straightforward. Those filters, the salt, and just make sure you keep up with those, and you should be good.
That's a filter wrench? That great.
Yeah.
Yeah. So that angle.
So you keep this salt at a third of the way up?
Yeah. I mean, even like you want to see moisture because this is half. I kind of said it was fine, but yeah, anywhere in this ballpark. You can pull this off too. You can look in there.
Oh, okay. And there's your tube.
Yep.
Very nice. Oh, so that's on a float. It's kind of on a float switch.
Mm-hmm.
Nice.
The design called for a pressure booster on the city water coming up to the. They didn't think they'd have enough pressure up here, so they put a pressure booster pump in. That's not really necessary because this building has plenty of water pressure. So we opened the bypass, and it works on the regular city water pressure. It's sufficient for the RO system supply. That's why this bypass is open and these valves are shut. But this pump is there in case there wasn't enough building water pressure.